So hi everyone, my name is Yash Dhananjay Devi, roll number 15, division E1. So we discuss about 2D and 3D geometric transformation. We take one topic, rotation. So let's talk about rotation. It is a type of geometric transformation. Rotation is a fundamental geometric transformation that allows object to be rotated around specific or point. This is a crucial concept in computer graphics engineering and design, enabling the creation of dynamic and interactive visuals. So, rotation, definition, application, and example. So, let's discuss about definition. Rotation is a circular movement of object around a fixed an axis or point. It involves changing the orientation of an object without changing its position. Let's discuss about how it works. Rotation is defined by angle of rotation, that axis point of rotation, and the direction of rotation clockwise or anti-clockwise or counterclockwise. So let's discuss about application. In computer graphics, 3D models are rotated to change their perspective and create dynamic visuals. Rotation is used extensively in animation, video games, simultaneous to create lifelike movements. So, discuss about the formula. So there are two formulas about for a rotation matrix. One for x nu y nu is equal to cos theta minus sin theta. Sin theta cos theta is the rotation matrix, and for homogeneous coordinate there are a 3 by 3 matrix formula x nu y nu and 1. 001 is additional point is there. So this is the 2D rotation formula, rotation around a point in a 2D plane, usually the origin. So let's discuss about our uh, examples. So this is an example from my notes. I create my own notes, and there are so many example. We take choose two example for this 2D rotation. Let's discuss about this example. So first example is rotate triangle A00B22 C42 about origin by angle of 45 degree. So there are we use this formula of rotation matrix. First one, cos theta minus sin theta cos theta. So we know there are cos 45 is 1 by root 2 minus sin 45 minus 1 by root 2. So put the value and get the answer. So this is the point A, B and C dash. This is the answer for this question. So second question is the rotate same perpendicular about pivot point minus 2 and minus 2. So first of all, first of all, we need to translate them. A 3 points, A 2 B 4 C 6 4. Then we rotate. So there are there 45-degree angle. So we put the value in this formula. Cos 45 is 1 by root 2 minus sin 45 is the minus 1 by root 2. Cos 45 is the 1 by root 2 and sin 45 is the 1 by root 2. And uh, there are two because of the point A 2 given. So put the value 2 and get the answer. So there are answer 0 to root 2, and similarly we get answers when putting the values in this formula. So this is the answer final. A double dash minus 2 2 root 2 minus 2, B double dash minus 2 4 root 2 minus 2, C double dash minus root 2 2 5 root 2 minus 2. So this is the answer. So next is 3D rotation. 3D rotation is the fundamental geometric transformation that object to be rotated around any axis in 3D space. This enabling changing the orientation and perspective of 3D model, which is crucial for creating dynamic interactive visuals in computer graphics, animation, and decimals. So how it works? So changing the direction an object is facing in 3D space, rotating an object around a specific point or axis. So there are similarly application for this 3D rotation like animation, video games, and etc. So let's discuss about this formula 3D rotation. So rotation about x-axis. While creating my notes, I am consider a three axis rotation about x axis, rotation about y axis, rotation about z axis. According to this, I created this formula. So for x axis, cos theta minus sin theta, cos theta for three rotation. And these are the 4 by 4 matrix we created. So like this, these are the formula for 3D rotation. 3D rotation is the rotation around an axis, x-axis, y-axis, z-axis in 3D space. So let's discuss about example. For given matrix, first apply a rotation of 45 degree about the y-axis, followed by rotation of 45 about x-axis. Determine the resultant matrix. So first of all, there are two rotation, Ry and Rx. So first of all, we use this formula rotation about y-axis cos theta 0 sin theta 0 0 1 0 0 minus theta 0 cos theta 0 0 0 1. So there are theta value is given 45 degree. Put the value and get the answer. So now we get ry and rx while putting the 45-degree angle. Now composite transformation for this we we need to product them Rx and Ry. So we get the R value 1 by root 2, 1 by root 2, 1 by root 2, 1 in diagonal space. So we given this matrix. So this answer matrix and this matrix we will product them and uh, find the resultant matrix. So we get this answer. This is the resultant matrix for this question. So this is the answer, and we know some basic rule, cos minus theta is cos theta, sin minus theta is minus sin theta. So let's discuss about the second example. uh, I read the second example. A rectangular parallelepiped has its length as 3 unit, 2 unit, and 1 unit on x, y, z axis with respect to perform rotation by 90-degree clockwise about x axis. This is the question for clockwise, and we discussed the formula for this is the formula for anti-clockwise. So we need to use minus sign in all over formulas like cos minus theta minus theta sin minus theta whenever uh, come clockwise in question, so we use the minus sign. uh, so there is theta value is 90 degrees, so put the value in formula and get the answer. So this is the rotation about x-axis. Rx we will find cos minus 90 is 0, minus sin minus 90 is 1, sin minus 90 minus 1, and cos minus 90 is 0. So uh, we get the transformation matrix, and according to diagram we find that these points A, B, C, D, E, F, G, H. So, uh, so this value is uh, put in the formula and get the answer. There are 4 by 4 matrix and 4 by 8 matrix. So, product will be 4 by 8 matrix. So, this is the answer for this question. This is the rotation by 90-degree clockwise. So this is the 90-degree clockwise answer. So let's summary. This presentation cover key concept in 2D and 3D geometric transformation with focus on fundamental of rotation. We will explore the mathematical formulas, practical application, and illustrative example to provide a comprehensive understanding of this essential topic. So thank you guys. We appreciate you taking the time to explore our presentation on geometric transformation. Thank you for your interest and engagement.